Greetings, everyone. Hey, this is Wild. Here is an overview and a demo of something that I finally got going, and it's awesome, and I wanted to show you. So first, I'm just calling this the Super Dynamic Demo Center because I'm happy and I felt like typing that. But this is a demonstration, an explanation of how an awesome project called Docker Flow Proxy and Docker Swarm in 1.12 works. So there's this awesome guy, Victor Farsick. Totally helpful. He's a Docker captain. That means he rules at community, ergo totally helpful, and builds awesome things. So he built something called Docker Flow Proxy, but before we get into that, a little bit of some details about Docker and 1.12. So Docker 1.12 has something called Swarm Mode. Swarm Mode allows you to designate a manager node and then join any other, let's just call them worker nodes in, so that all of those nodes surrender their compute resources to this cluster in a way, or this swarm. And Swarm has, in 1.12, has container-aware load balancing. It has overlay networks and an internal DNS. So on an overlay network, for example, you don't really need to know the IP address. You can actually just talk to the container by its name. Docker will handle getting you to the right place. Docker 1.12 also has something called services. We're used to launching containers. And in previously, we would use Docker Compose to maybe put containers on a particular node. And Docker Services is a lot more flexible and allows us to control services with a single command. We can define them, obviously. We can list them. We can get more details about them, inspect them, remove them, upgrade them, etc. Well, Docker 1.12 Swarm has container-aware load balancing and an internal DNS, but it doesn't really know about external DNS, and there's really no slick way inside of the framework of Docker to just map external domains and put a proxy in front of it and mask all this other stuff. So Victor comes along and builds this awesome project called Docker Flow Proxy. The job of Docker Flow Proxy, it has two parts. We'll explain them in a second. But the proxy service watches for a new Docker service creation, updates an HA proxy node. HA is a reverse popular proxy with a new configuration for each container. Why is this awesome? It allows us to map a public domain name to a container that is inside a Docker overlay network and proxy communication between the client and the container. So the outside world really never has access to these particular containers, and we're doing it all through proxy. Now, this probably sounds kind of complex, but it's really easy when it works. So check this out. Here's my scenario that I have for this particular demo. I got it all working today, and I'm going to look about getting this into production. So first of all, I've joined 4 nodes. And what I mean by nodes, and right now these are just AWS instances with the proper Docker TCP and UDP ports open between them. And I've created one manager node by just typing Docker Swarm init. From that, I get a join command, and I've joined each of these nodes into the swarm. Note, Swarm has an ingress network, and it automatically routes inbound requests where they should go. So, for example, if it's looking for a particular DNS name or it's looking for a particular port, it really doesn't matter which node that you run into on the swarm. The ingress network will route that where the service should go. It actually works as simple as I said. It's a pretty hard thing to accomplish, but it actually works. For my particular demo, I've mapped DNS names to each of these nodes in star.domain. You'll see it in a second, but I don't have any physical domain names mapped inside of my hover DNS. I just have said star.domain is mapped to 4 different IPs. And then all of my Docker images for this particular presentation that I use, other than Victor's images, are stored in my own Docker Trusted Registry, which is a product that we own. Okay, so now hang on to your seat because we're going to go deeper into the rabbit hole. All right, this is simple but effective. Now, again, if you're not too familiar with Docker Swarm and some of the parts of the Docker framework, Docker has software-defined networking, aka what we call an overlay network. This is simple but effective. Okay, so we're going to create two networks here. One, there's a command we use to create a network. It's already done, so you don't need to watch me do that. But I have a Docker network called Proxy. That's just the name of it. And I have another Docker network called Splunk Ninja. I'll explain in a second why I have two different networks. But, to be simple, you basically can choose where you want networks accessed from and what things are joined on which network. Now, I've taken these two services, and we're going to demonstrate this for you in a second. Victor's Swarm Listener and Flow Proxy, these are the two images that turn into containers that are required for this. They're going to run on the Proxy network, and the Proxy network is going to listen for all the communication from the outside world. I have another network called Splunk Ninja, which, for example, I might want to take and have a copy of Splunk running as my licensing node containing all of my licenses. I don't want that accessible to the outside world, but I want it to accessible to any Splunk instance I have running. But the proxy also needs to see the Splunk instances as well because it's going to need to route traffic. So when we launch these, we're going to create the service with the proper command line switches, and one of these switches is going to be -network. And we're going to join each of these Splunk demo containers to both networks. So they're going to bridge across both networks. So any services on the Proxy network or on the Splunk Ninja network can see each of those green boxes. And those green boxes are going to represent, in a minute, images that have turned into containers. So the way it works is a service gets created with the proper command line switches. Docker Flow Swarm Listener notices it. Because inside of Docker Swarm, there's a service registry in a way that when you create a service, it's aware of it. So when Swarm Listener sees that, it sends a configuration update to Docker Flow Proxy, that HA proxy. It's going to create some new configuration files in there. It's going to update them and delete them as I need. And that external host name is now mapped to the internal service regardless of where it's deployed on. I just eliminated like 99.732% of DevOps tasks for this entire project, and that's pretty awesome because now I can publish Docker images, turn them into containers, and make my demo environment really badass and flexible. Here's the bonus part. You know what's going to happen when I type this, right? Docker service scale, OI-demo. OI-demo is one of my demos, equals 10. It's going to fire up 10 containers, and it's going to float them across all my nodes in a fairly even way, and it's going to load balance across them. So I can scale up and down at will. Sunglasses, happy emoji, right? So let's show you that this actually works. Okay, more details. First, use Google. Find this. Just Google Docker Flow Proxy Swarm Mode. You'll find Victor's GitHub repository with some awesome documentation. You can run this thing in automatic mode or manual mode. I like things in automatic other than cars, so I went with automatic mode. And there's a bunch of great documentation on here. I'm going to skip the part where we've created the network, but we're going to go right into starting from ground zero. So what I have here behind you is I have my worker nodes. If we look here, worker node 1, worker node 2, worker node 3, and a manager node. If I do docker node ls, we can see this is my swarm. It has my manager node and then 3 worker nodes. For the purposes of this demo, I basically just ran the watch command in Linux, watch-n0 docker ps. So that'll allow us to monitor what containers are running on here. All right, so first thing I need to do, got some of this stuff in Visual Studio Code. I'm going to create the Swarm Listener. So this is from Victor's documentation, and it's basically going to create the thing that listens to Swarm having new services. So we'll pop that on there. That's going to run, and it's going to run on one of the nodes. I don't know which one it's going to run on. I really don't care, actually. It's nice to not actually care. Then I need to run the proxy. And here, just really quickly before we copy and paste, its name is proxy. We are exposing ports 80 and 443. It is listening on the network proxy. It has a mode called Swarm, And it's linked to the listener container by this particular switch here. So we'll paste that in there, and that's running. We'll see where it ends up. So if you look at it here, down on the red one here is actually worker node 3. So it didn't launch on the manager, and it launched on worker node 3. That's kind of cool. Again, let's just do docker service ls, and that's going to show us what the services we are launched, what their names are, their IDs, which image was launched, and the number of replicas, right? When I do that scale thing, that creates more replicas. Okay, so far we have the service up and running, and Docker Flow Proxy is kind of waiting for us to do some more stuff. Now, before we start typing commands and seeing awesome stuff happen, there's one little other part that I mentioned in my presentation that I want to make sure I show you right now. So I use Hover as my DNS name system here for this particular demo. And I have this domain, splunkninja.com. And then, as we can see, I have 4 entries, each of them for star.demo, which represents the subdomain name. So, for example, michael.demo.splunkninja.com, okay? Or, lightbulb.demo.splunkninja.com. So, anytime any wildcarded domain name is hit here, it's going to pick any of these. Any of these particular nodes can respond. I could have one respond or all respond. It doesn't matter. But this is all I did here. So just a simple DNS mapping so that, your browser can actually get to one or more of my nodes. Don't really need to have all of them in here. Just need to have technically one because of the way the ingress network works. All right. So let's actually make some stuff happen. Now, you may or may not know what Splunk is. It is an awesome machine data analytics, search, reporting engine. I work at Splunk, and I'm going to do some cool demo stuff. But I figured it would be nice if we could bundle up Splunk and our demos into a set of Docker images that anybody could run on their laptop or in their own data center. And in my case, I'm going to see if we can basically make our own demo data center all with Docker without having to SSH, deploy, do any of this other garbage, okay? So, let's make some stuff happen. First, I'm going to go over here to Visual Studio Code because I have some things written down for you. 1, here's my Docker service create command. So, pay attention, pause the video, look at this for a second. So, we're saying Docker service create. I'm giving it a name. This one's going to be called ITSI demo. I have an environment variable here that I need to put in because Splunk requires you to accept the license agreement or the terms of service. And then, as you can see, I'm joining this on the network Splunk Ninja and the network Proxy. So this container is going to sort of be in both networks at the same time. Now, here are some switches that are required for the Docker Flow Proxy. Victor uses labels. So when I say -- label, there's a few of them that are here. The ones that I really care about are these 3. com.df.service domain. So this is the domain name that then really the proxy server is going to listen to, and it's going to route it to the container. So the swarm listener is going to pick this up, and it's going to tell the proxy node, hey, here's some new configuration. The service path, in this case, the root directory of that particular web server is what we're serving up. And on the inside of this network, not on the outside, but on the inside Splunk Ninja network, this container is going to be running on port 8000. And it's really only exposed just to the network itself, not to the whole internet. And then finally, the star of the show, other than Docker Flow Proxy, is just the Docker image that I'm going to use. Okay, so let's launch this one here. I'll copy this, get rid of this, and we'll go ahead and launch that. All right. So what's this is going to run right now, it basically is going to launch a copy of this particular demo, and it's running here on, where's this running? Worker node 1. So it takes a few seconds for this thing to run. So while we're at it, we might as well do another one. So I'll pop over here, and we'll grab another one here. We'll grab this one called AWS demo. Splunk has an app for Amazon Web Services. I'm going to run that. And that's now going to start an instance of Splunk. In this case, it's running on worker node 2. And again, I'm going to clear this real quick and we'll do Docker service ls. As we can see, we've got 4 services running. And if we want to interrogate a particular service, Docker service ps, we can actually see that this particular service is running over here on worker node 2. Just a few more things. There's a lot of other things you can get out of it, things that you can inspect. But what would be nice is if we actually proved this worked. So I'll just bring up my browser here. And if we look at, I have the AWS and ITSI ones going. So we'll just say aws.demo.splunkninja.com. Boom. Now this one here, this looks like a regular copy of Splunk. In this case, it's running 6.5. I'm just going to log in here real quick. I don't need to change my password. And as we can see, we've got the Splunk app for AWS and the add-on for AWS. I didn't deploy any servers. I just deployed a container. And the proxy service got updated with the host name that I wanted it to get updated. Now that's pretty freaking cool because you know what's going to happen when I type in itsi.demo.splunkninja.com. It's going to pop up another instance of Splunk. And right down in here, I'm looking at this particular image turned into a container, has Splunk's IT Service Intelligence product. And it looks like, it's still this particular demo is setting up. It has a couple of steps to get going. And, we could go to our heart's content. As a matter of fact, let's just do one more because, there's always one more thing that you have to do. We'll take our pretty popular operational intelligence demo. Pop this up here. Now this guy is running. Where's it running on? I don't know. We'll see. So the OI demo here is now also running on the same node the AWS demo is running. Really quickly, if you're a Docker person and you recognize what's happening here, these are the ports that are exposed, but they are not externally exposed to the host itself. They're only available to containers that are a member of that particular network. Let's try one last time. We'll go to oi.demo.splunkninja.com. This guy's running. This has an older copy of Splunk on it. Looks like I got some development work to do. Just need to crank out my Docker image with the new version of Splunk, which is nice because then I can just probably do a Docker service upgrade. So here we have operational intelligence. I'm not going to go through any demos right now, but as you can see, we basically did no work. We launched something correctly. We had some properly built images, so that you got to do. But Victor Farsik's Docker Flow Proxy and how Swarm 112 works is genius. So here's the one more thing of where I'm going. We could do this. If we do Docker Service ls, we'll do this again. Let's take and scale this. Docker Service scale. And we'll say 10. Watch this. Boom. And now all of these nodes have been directed to start containers. And they're on their way starting up. Okay? Now, the nice thing is when I hit oi.demo.splunkninja.com, and Docker Swarm will take my request and route me to one of the containers that's available. Which one? I don't really care because I have the same service replicated across all of these particular nodes. And if one of the nodes goes down, Swarm is going to take care of making sure that I get to the right place as the user. So let's take the wall down. Docker service rm OI demo. I know, it's sad to see it go. It's terrible to see it go. But it was really brilliant while it lasted. A few other things I got to work out. Since I just got this working, I need to practice rolling upgrades with Docker services because you can upgrade them. In this particular scenario, I need to schedule container restarts because I have people doing demos and they're creating objects and dashboards and other things. And probably at the end of the night, I need to restart them instead of going in and manually wiping them off. I'm working on crossing clouds. So I want to see how reactive Swarm is if I have something across AZs or even in different clouds. But heck, if I had to set up 3 different particular swarms that were isolated, no big deal. And the last thing, I need to do some minor Splunk node configuration because for this deployment, I really need to take every container and have its authentication backed by an LDAP. So I think I should probably be able to just tweak my Docker image startup where I pipe in some configuration information into my Splunk node so that it goes after the Active Directory server that I particularly need. But I'll tell you one thing, this thing was awesome, and I have to give huge props to Victor for creating this amazing project, this Docker Flow proxy that works fantastic. So anyways, Victor, you're awesome, and this is my project I'm working on, and I think we're going to be able to move this into production with a few extra tweaks.